All right, this is the Messenger mission to Mercury presentation. So to get started, let's talk a bit about Mercury. It's the smallest planet in the solar system, just under 5,000 kilometers in diameter, and the internal temperature is relatively cool. And it's cooling down as part of planet's life cycle. And we're able to see this cooling because of phenomena on the outside of the planet called scarps. And scarps cause the planet sort of to condense and to shrink in diameter, sort of to wrinkle and to wither. Um, and this makes the planet more dense. It's also an indication of cooling and of the planet continuing its life cycle. Mercury is the second densest planet in the solar system. The most dense would be Earth. And this image you're looking at here is an image of Mercury, of course, taken by the Messenger spacecraft, sort of a combination of lots of its images. So let's talk a bit about the mission itself. It began on the 3rd of August, 2004, and ended on the 30th of April, 2015. It got launched into space and made the long trek towards Mercury, taking pictures of Venus along the way. And this was the second of NASA's missions to Mercury. This was the first one to orbit the planet. And that was very helpful because we got lots of pictures from lots of angles. And we were also able to do some more fine measurements of the magnetic field and some other aspects of the planet. The picture that you're looking at here is of Mercury's polar craters on the poles of Mercury. And these are cool because these parts of Mercury don't see the sun. And they also have water ice on them, which we were able to confirm. And we'll talk more about that in a second. But this is just some of the information that we were able to gather. And the Messenger spacecraft stands for Mercury Surface Space Environment Geochemistry and Ranging Mission, with kind of a weird looking acronym. So some of the unique findings, like I mentioned, we got a map of Mercury's unseen side, the part that we can't see from Earth from telescopes because Mercury doesn't really spin like the other planets do as fast. And so there's a lot of parts of the planet that we just hadn't seen before until we sent the messenger over. And this image is some more pictures of the polar ice. We're able to figure out that we're able to confirm, based off of our hypotheses that we gathered from looking at Mercury from telescopes, that Mercury does in fact have water ice, and it's mainly on the poles, similar to Mars. And yeah, so that's kind of neat. And they're inside the craters of Mercury. Some other neat things we found. This is a picture of a false color view of the planet that we're able to look at and analyze and determine that there is sulfur. And sulfur is important because it shows that there's volcanic activity. So this, we're able to learn sort of about its past. This indicates that there was once volcanism, but there's no longer. So this makes Mercury very similar to the moon, as well as Earth and to Mars and to Venus. So, you know, it's a very standard rocky planet in some ways, but in some ways it's not. One of the more unusual parts about Mercury is that, and that we were able to determine based on the messenger voyage, we were able to really confirm what we had discovered previously, was that the core is very large. It's unusually large, and Mercury is also very, very dense, partly because of this core. Mercury's core is about 85% of its radius. That's very, very large. Earth's is only 50%. And as you can see from this diagram, the crust is also very thick and much thicker than Earth's. And that's because of the way Mercury has aged. Like I say, this is us sort of looking into the future to see sort of the fate of planets like ours or like Mars or even the moon, what they will end up looking like both externally and internally. And these are my references, and I enjoy seeing and answering your questions. Thank you.